Hi, this is Miguel Joseph E. Romilla, and I'm from STEM 116. This video will show you on the topic that we discuss in statistics. For example, permutation. What is permutation? Permutations are different ways in which a collection of items can be arranged. For example, the different ways in the alphabets A, B, and C. You can arrange them in many ways, like ABC, ACB, BCA, CBA, and CAP, and BAC. The ABC and CBA are not as the same order of arrangement. It is different. A permutation is an arrangement of items or events in which order is important. Permutation helps us to find total number of ways that items can be chosen when order does matter. A key tool in calculating permutations is factorials. Factorials are written with an exclamation point. For example, these are factors. They are written with exclamation points. One could say that a permutation is an ordered combination. The number of permutations of an object taken at a time is determined by the following formula. This formula is the formula n factorial parenthesis n minus r factorial. One famous joke for a permutation is the difference of a combination lock should really be called a permutation lock. The order you put in the number of lock matters. In permutation, repetition is allowed. Could be 3 3 3, 5 5 5, or 9 9 9. These are allowed. No repetition. For example, for the three people in a running race, you can be first and second. Only one should be first, second, and third. That is the no repetition. Again, permutations is an arrangement of items or events in which order is important. Permutation helps us to find the total number of ways that items can be chosen when order does matter. Next is combination. Combination is a selection of items from a collection, such that, unlike permutations, the order of selection does matter. A combination is a mathematical technique that determines the number of possible arrangements in a collection of items where the order of the selection does not matter. In combinations, you can select the items in any order. Combinations can be confusing with permutations. However, in permutations, the order of the selected items is essential. For example, the arrangement of AB and BA are equal in combinations, considered as one arrangement, while in permutation, the arrangements are different. Combinations are studied in combinatorics, but are also used in different disciplines, including the mathematics and finance. One example of combination is 6 friends wants to play chess with one another. 6 friends and they want to play chess with one another. The formula is 6 parenthesis 6 then 2 parenthesis over 2 factorial equals 6 times 5 over 2 times 1. The answer is 30 over 2, so it will become 15. And that's the 15 games they have to play with one another. Another examples of permutation. How many words can we make using the letters A, B, E, and L? Again, how many words can we make using the letters A, B, E, and L? We have 4 choices for the first letter. We have 3 choices for the second letter. For the third letter, I mean. For the second choices, we have 2 choices, and for the last one, we have only 1. Again, for the first letter, we have 4 choices. For the second letter, we have 3 choices. For the second letter, we have 2 choices, and for the last letter, we have only 1 choice. Hence, the number of words is given by 4 times 3 times 2 times 1, and this is equal to 24, because 4 times 3, 12 times 2, 24 times 1 is equal to 24 again. Again, how many words can we make using the letters A, B, E, and L? In the first letter, we have 4 choices. In the second, we have 3. In the second letter, we have 2. In the first letter, we have 1. You need to multiply this 4 times 3 times 2 times 1, like here, and then your answer should be 24. Another example is, how many 2-digit number can you make using the digits 1, 2, 3, and 4 without repeating them? This time, we want to use 2 digits at the same time to make 2-digit numbers. For the first digit, we have 4 choices. First digit, we have 4 choices. And the second digit, we have 3 choices. 4 to 1 is used already, or 4 and 1. Using the counting principle, the number 2 digits that we can make using 4 digits is given by 4 times 3 times 12 is equal to 12. Again, how many digit numbers can you make using the digits 1, 2, 3, and 4 without repeating the digits? This time, we want to use 2 digits at the same time to make 2-digit numbers. For the first digit, we have 4 choices. 4 choices for the first. For the second digit, we have 3 choices. 4 to 1 is already used. And using the counting principle, the number 2 of digits that we can make using 4 digits is given by 4 times 3 is equals to 12. The problem is that arranging of 2 digits out of 4 in a specific order. This is called permutating. It is the most important idea in permutation. The order is very important. When you use digits 3 and 4 to make a number, the number 3, 34, and 43 are different. Hence, the order of the digits 3 and 4 is important. In general permutating, items out of set is written as like this: N, P, and R, N. And the formula is given by NPR is equal to N slash N minus R. There. That's the formula given. Again, the most important idea in permutation is the set. It is very important. The order of the set is very important. Next example. How many three-letter words can we make with the letters in the word love? How many three-letter words can we make in the letters of love? There are 4 letters in the word love, and making 3-letter words is similar to arranging these 3 letters, and order is very important since L-O-V and V-O-L are different words because of the order of the same letters L, O, and V. Hence, it is a permutation problem. The number of words is given by 4 potential 3 equals to 4 plus 3 is equals to 24. Again, there are 4 letters in the word love, and making 3-letter words is similar to arranging these 3 letters. These L-O-V and V-O-L are very important. Are very different because of the order of the same letters L, O, and V. Hence, yes, it is a permutation problem. The number of words is given by 4, 3 is equals to 4, the exclamation point, parenthesis 4 minus 3 exclamation point, and then the answer is equal to 24. Here are examples for combinations. How many lines can you draw using 3 non-collinear points A, B, C on a plane? Again, how many lines can you draw using 3 non-collinear points A, B, C on a plane? You need 2 points to draw a line. The order is not important. Line AB is the same as line BA. Line AB is the same with line BA. These are the same. The problem is to select 2 points out of 3 to draw different lines. If we proceed as we did with permutations, we get the following pairs of points to draw lines. If permutation, we get AB, BA, CA, AC, BC, CB. There is a problem. Line AB is the same as line BA, same for lines AC and CA, and BC and CB. The lines are AB, BC, and AC, 3 lines only. So in fact, we can draw 3 lines and not 6, and that's because in this problem, the order of the points A and B is not important. The combination problem, combining 2 items out of 3, and is written as follows. Again, the lines are line AB, line BC, and line AC. Again, in this problem, line AB is the same as line BA, same for lines AC and CA, and BC and CB. The lines are AB, BC, and AC, 3 lines only. So in fact, we can draw 3 lines and not the 6 because in this problem, the order of the points in A, B, C is not important. Second example, we need to form a side team in a class of 12 students. How many teams can be formed? Again, we need to form a side team in a class of 12 students. How many different teams can be formed? There is nothing that indicates that the order in which the team members are selected is important, and therefore it is a combination problems. Hence, the number of teams is given by this. This is the solution. Or it's equal to 792. Again, we need to form a side team in a class of 12 students. How many teams can be formed? There is nothing that indicates that the order in which the team members are selected, and therefore it is a combination problem. Hence, the number of teams is given by this formula. 12 is equal to 12 exclamation point, or parenthesis 12 minus 5, parenthesis exclamation 5, and then exclamation point, and it is equal to 792. Another problem. In how many different ways can the letters of the word corporation be arranged so that the vowels come together? The word corporation has 11 letters. It has vowels. It has the vowels O, O, A, I, O. And it is in it, and these 5 vowels should always come together. Hence, these 5 vowels can be grouped and considered as a single letter, that is C, R, P, R, T. Hence, we can assume total letters as 7, but in the 7 letters, R occurs 2 times, and the rest of the letters are different. R occurs 2 times. Number of ways to arrange these letters here. Number of ways, letters. Equal to 7 times 6 times 5 times 4 times 3 times 2 times 12 times 1 is equal to 7 times 6 times 5 times 4 times 3 times 2 times 12 times 1, and is equal to 2, 5, 20. Let's try that on the calculator. So we got 7 times 6 times 5 times 4 times 3 times 1 is equal to 2, 5, 20. Again, 7 times 6 times 5 times 3 times 2 times 1 is equal to 2, 5, 20. In the 5 vowels, the vowels, O occurs 3 and the rest vowels are different. O occurs 3 times. And the other letters. Number of ways to arrange the vowels among themselves. So 5 equal to 5 times 4 times 3 times 2 equal to 20 only. Hence, the required number of phase are so 2520 times 20 is equals to 50,400. This is the width. Final answer. Again, the word corporation. It has 11 letters. It has 5 vowels. And it has 7. The R is repeated 2 times. So in letters, 7 times 6 times 5 times 4 times 3 times 2 times. So the answer is 2,520 letters. And in the vowel section, O is repeated 3 times. So it will become 5 times 4 times 3 times 2 times 1. And the answer is 20 because 5 times 4 only. And then for the final answer, you will multiply the answer in letters and in vowels. In letters, we had 2,520. In vowels, we had 20. So 2,520 times 20 is equals to 50,400. This is the topic that I discussed. Permutation and combination. I hope you understand something from it. Again, I'm Miguel Joseph E. Romilla from STEM 116. Thank you for watching and listening. Goodbye.